Okay, in this section we are going to look at sum and difference formulas, but today for sine and tangent. So at the bottom of page 431 and the top of 432 in your textbook, it derives the sine, sum, and difference formulas, which are right here in this outlined yellow box. You can read them and look over them. I would like to write them one time for you. The way that I remember them is that everyone has to have a turn to go together. So sine of A plus B is sine of A cosine of B. Sines avoid things. So if it says plus, you do plus. And then the angles switch places. So you can write cosine A, sine B. This way both trig functions, sine and cosine, get a chance to be with both angles. The only difference is if it were a minus right here, you would use a minus right here. That's it. That's the whole formula. And then right here through the notes, it shows you how to derive the tangent formula using two different sum and difference formulas. Tangent is sine over cosine. So here's the cosine sum and difference. No, sorry, the sine sum and difference over the cosine sum and difference. They go through the outlined algebraic steps, coming up with this final formula, which is found on the next page of your notes. So right here is your tangent sum and difference formulas. And for this one, I just remember everyone takes turns and the signs flip-flop. So for this one, tangent of A plus B is going to equal tan A tan B. If this sign is plus, then you plus on top. And then on the bottom, you have to do 1 minus, and now they multiply. Tan A, tan B. If it were a minus in the equation, the only difference is that this one would be a minus, then this one down here would be a plus. But same idea as cosine. We're going to use things we know from the unit circle to rewrite things we don't know, and then evaluate them. So for this first formula, I can rewrite this as sine of 45 plus 30 degrees. That is the same thing as sine of A plus B. That formula equals sine A cosine B plus cosine A sine B. So in our case, my A is 45 and my B is 30. So I'm going to have sine of 45 degrees cosine of 30 degrees plus cosine of 45 degrees sine of 30 degrees. Sine of 45 degrees is root 2 over 2. Cosine of 30 is root 3 over 2, plus cosine of 45 degrees is root 2 over 2, and then finally sine of 30 is 1/2. Multiply straight across, so you get root 6 over 4 plus root 2 over 4, which we can write as root 6 plus root 2 all over 4. Letter B, we're going to work backwards. It's already expanded out, so we have to recognize what it is first. So this is sine of A cosine of B minus cosine of A sine of B, which we know came from sine of A minus B. So this is sine of 40 minus 160. That's sine of negative 120. Sine at negative 120, we go down 120 degrees like this, is negative root 3 over 2, and there's your answer. for this last problem, we're going to get to use tangent formulas. And so first of all, let's figure out how we can make this. Tangent of 7 pi over 12 is 4 pi over 12 plus 3 pi over 12. That's the same thing as tangent of pi over 3 plus pi over 4. And just a little note, this is going to be the prettier of the two versions. But if you were to ever use 2 pi over 12, which is the same thing as pi over 6 for tangent, it's not so great. It's not horrible. It's an algebra battle. So just be aware, if you can avoid and you can find a way not to use 2 pi over 12, please by all means don't use it. So the formula for tangent when it's tangent of a plus b, tangent of a plus b equals tangent of a plus tangent of b, and then we divide by 1 minus tan a tan b. So this means I have tangent of pi over 3 plus tangent of pi over 4 over 1 minus tangent of pi over 3 tangent of pi over 4. So let me make all this a little bit smaller. Let's evaluate this. This equals, you can use your hand trick, but tangent at pi over 3 is root 3. Tangent of pi over 4 is a 1. 1 minus root 3 times 1. So this cleans up into root 3 plus 1 over 1 minus root 3. And that would be the answer, except for tangent, fractions, radicals. This piece right here is the problem. I can't leave a root in the bottom. So to get rid of the root in the bottom, I have to multiply by the conjugate. So I have to multiply the top and the bottom by 1 plus root 3 over 1 plus root 3. And I'm going to have to literally foil it out on top and on bottom. So when I foil the top, root 3 times 1 is root 3. Root 3 times root 3 is a 3. 1 times 1 is a 1. And 1 times root 3 is another root 3. On the bottom, I'm going to get 1 times 1 is 1. 1 times positive root 3 is a positive root 3. Negative root 3 times 1 is a negative root 3. Positive root 3 times a negative root 3 is a negative 3. This cleans up into, on top I have 2 root 3's. 1 root 3, 2 root 3's. Plus 4. On the bottom, these two cancel off. And you're left with 1 minus 3, which is negative 2. And then you can divide both the top pieces by that negative 2. So we get negative root 3 minus 2. And that is your final answer. Okay, so now we're going to apply formulas with variables. So this first one we can expand out into sine of a plus b, sine of a, cosine of b, plus cosine of a, sine of b. And as silly as you might think it is that I keep writing these formulas, I write them over and over again, and it's part of why I have them memorized. A is 30, and b is theta. So this becomes sine of 30 cosine of theta plus cosine of 30 sine of theta. This is now 1/2 cosine theta plus root 3 over 2 cosine theta. Because these have the same denominators, I could even write this as cosine theta over 2 plus root 3 cosine theta over 2. And because the denominators are the same, I can write this as one big fraction. Cosine theta plus root 3 cosine theta all over 2. Tangent. This formula expands out to tangent of A plus tangent of B over 1 minus tangent of A, tangent of B. A is 45 and B is theta. So this equals tangent of 45 plus tangent of theta over 1 minus tangent of 45, tangent of theta. Tangent of 45 degrees is 1 and 1. So you get 1 plus tan theta over 1 minus tan theta, because 1 times anything is the other thing. And that is your final answer. This is sine of A minus B, sine A cosine B minus cosine A sine of B. A is my 180, B is my theta. So I get sine of 180 degrees, cosine of theta, minus cosine of 180 degrees, sine of beta. Cosine of 180 is 0, and 0 times anything is 0, so this whole side is 0. Sorry, sine of 180. Cosine of 180 is negative 1, and then I have this minus sign in the front, so it becomes a 1. So this is 1 times sine of beta, which I forgot to change into a theta, sorry, theta. So 1 times sine of theta is just sine theta. Okay, those infamous triangle problems. So let's do this piece by piece. It says that sine of A is 4/5, and A is between pi over 2 and pi, which means pi over 2, pi. I live in the second quadrant. Sine is my y over my r, so my y is 4, my r is 5. You can do Pythagorean theorem, or you can know that this is a special Pythagorean triple. So this side is, remember, it's negative 3. X is negative in the second quadrant. And then cosine of beta, it tells me that beta is between pi and 3 pi over 2. So I'm in the third quadrant. And cosine is my x over my r. So my r is 13. My x is going to be negative 5. And then if you do the math here, this should become a negative 12. It's also a Pythagorean triple, a 5, 12, 13 triangle. And so now we do our formulas. This is sine A cosine B plus cosine of A sine of B. Cosine of sine of A on my A triangle is 4/5. Cosine of B, they told me, is negative 5/13, plus cosine of my A triangle is negative 3/5. And then sine of my B triangle is negative 12/13. And I forgot, I should label this. This is my A, this is my B. 4 times negative 5 is negative 20/65 plus 36/65. And then you can add the numerators because you already have common denominators, which will get you a 16/65. there's your answer. Okay, tangent of A plus B. So let's write the formula first. This thing oops, I want to be in black, sorry. This thing equals tangent of A plus tangent of B over 1 minus tan A tan B. So this equals tangent of my A triangle. Tangent of my A triangle would have been my y over my x, so this would have been 4 over negative 3 plus tangent of my beta triangle would have been 12 over 5, because the negative divided by negative is a positive, over 1 minus 4 over negative 3, 12 over 5. So let's, the bottom right here, you multiply straight across. So you're going to get 1 minus negative 48 over 15. So on the bottom I can call this 15 over 15 minus a negative, so plus 48 over 15, which gets you 63 over 15. So that's the bottom. On top, common denominators, I need to find those. So I'm going to multiply this first fraction by a 5 over a 5. And the second fraction I'm going to multiply by a 3 over a 3. So in the top I would get negative 20 over 15, plus the second fraction of the numerator I'd get 36 over 15, which when I add those together gets me negative 16 over 15. So now when I put this together, I have negative 16 over 15 over 63 over 15. So you keep, change, and then flip. The 15s cancel off. You are left with this is not negative 16. Positive 16. Sorry. Negative 20 plus 36 is a positive 16. Okay. Keep, change, flip. 15s cancel out. You get 16 over 63. The last question, a little bit of thought. Just thought. It says the quadrant of A plus B. So sine of this angle A plus B was positive. Tangent of this angle A plus B was positive. Tangent is only positive in 1 and 3. Sine is only positive in 1 and 2. Therefore, for both of these things to happen, it must have happened in quadrant 1. Okay, last problem. Okay, so this is sum and difference in theory twice. I need to verify this statement. It has 2 sum and difference pieces. So I'm going to do this piece first. So sine of A plus B is sine of A cosine of B plus cosine of A sine of B. So this becomes sine of pi over 6 cosine of theta plus cosine of pi over 6 sine of theta. Sine of pi over 6 is 1/2 cosine theta plus cosine of pi over 6 is root 3 over 2 sine theta. So that's just my blue piece. So blue thingy right here plus red thing. Cosine of A plus B expands into, from last section, cosine A cosine B minus sine A sine B. So I'm going to have cosine of pi over 3 cosine of theta minus sine of pi over 3 sine of theta. Cosine of pi over 3 is 1/2
Tristan, this is not
cosine theta minus root 3 over 2 sine theta. So I don't really need the parentheses. I can drop them because I'm just adding in the middle. So this piece right here, a half a cosine theta plus a half a cosine theta, is a whole, one whole cosine theta. And then this root 3 over 2 sine theta cancels out with negative root 3 over 2 sine theta. They undo each other. Well, look, I was left with cosine of theta, which is what I was trying to verify. You did it.